Mass spectrometer question 1. A mass spectrometer is used to analyse a sample of lead containing two isotopes, lead-204 and lead-206. Each ion has lost one electron, and they're accelerated through a potential difference of 20,000 volts. Calculate the speed of both ions. Well, for this we need the electron gun equation, and we want to find the speed, so rearranging for the speed we get this expression. The charge on the ions is the charge on the electron, as they've lost one electron. Putting in the numbers for lead-204, we have the mass as being 204 multiplied by the atomic mass unit, which is given on the datasheet. This gives a speed for the lead-204 ions of 1.374 times 10 to the 5 meters per second. Now the same calculation for lead-206, with the mass now being 206 times the atomic mass unit. This then has a speed of 1.368 times 10 to the 5 meters per second. In reality, a range of speeds are obtained, and the velocity selector only allows ions with a speed of 1.30 times 10 to the 5 meters per second through. The electric field has a strength of 30,000 volts per meter, so what magnetic flux density will provide particles of the required speed? Well, to pass through the velocity selector, the force due to the electric field, which is given by the charge on the ions multiplied by the electric field strength, is equal to the force due to moving through the magnetic field, given by the magnetic flux density multiplied by the charge on the ions and their velocity. We want to find the magnetic flux density B, so we can rearrange to get this expression. Cancelling the charge on the electron from top and bottom gives this. We can now put in the values we have, giving a magnetic flux density of 0.23 Tesla. The ions then enter a magnetic field of 0.7 Tesla. Calculate the radius of orbit of the two isotopes. Well, for this, the force due to the magnetic field, BeV, is providing the centripetal force for the ions, mv squared over r. We want to find r, so we can rearrange to get this expression. Cancelling this v with one of these gives this. Now for lead-204 we can put in all the values, which gives a radius of 0.393 meters. Performing the same calculation for lead-206 gives it a slightly larger radius of 0.397 meters.